viewers, good afternoon. Welcome back to Matafe Academy. My name is Inifon Ekbo. In this section of this video, we will be discussing functions. But before we go into the definition of function, let's first and foremost understand what function is and the concept behind it. But before we start, please subscribe to the channel page and always remember to click on your notification buttons for more videos. And always do well to let Matafe know the topic you wish us to handle. Okay, so let's start. We want to look at functions today. Let's consider this. If you have 3x plus 2 equals to 0, what you know this to be as equation, right? You always know this to be, we call this an equation. Yes, because we have an unknown that we can always look for. But what if we have something like this, the same equation, but it is written in this form, 3x plus 2 equal to what? Y. We call this a function. And why do we call it a function? Because we have two unknown variables here. One is what? Dependent, and the other one is independent. We have this to be what? Dependent variable, and we call this what? Independent variable. Because of the presence of the independent and the dependent variable, we call this equation a function. And so you also know that y can also be represented as what? F of x, function of x. So we can always represent y to be the function of x. In that case, we can rewrite this equation as f of x to be equal to what? 3x plus 2. And we call this what? A function. This is what? A function. So having this as a function, now there's what we call the input and there's what we also call the output. So we have this to be what? This to be what? This is your output. And we have your x here to be what? The input. Meaning that any value x take, you will always have what? A unique value to be what? An output. For example, let's consider the value of x. Let's consider the value of x to be what? 1, 2, 3, and 4. If you consider the value of x to be 1, 2, 3, and 4, I hope you are seeing the board very well. And you substitute wherever you see f of x, you put what? F of 1 into this equation. What will you have? This simply means that everywhere you see x, you substitute the value of what? X. So that we have what? 3 of 1 plus 2 to be what? 3 times 1 is what? 1 plus 2. We have this to be 5. That is what we have when you substitute the value of x to be 1. And when you substitute the value of x to be 2, what do you have? 3 of 2 plus what? 2 to be what? This is 6 plus 2. That would be what? 8. We do the same thing to 3. So that we have 3 into what? 3 plus 2. That would be what? 11. And we have f of 4 to be what? 3 of 4, which is 12 plus 2 to be what? 14. Now having this simply means that any value x takes, that the outcome will also be a unique outcome. So we can rewrite this to be, let's rewrite it here. Let's rewrite all of this to be an order pair. We can write this outcome as f of x, y to be a set of 1, 5. When x is 1, the outcome is what? 5. When x is 2, the outcome is what? 8. When x is 3, the outcome is what? 11. And when x is 4, the outcome is what? 14. And we close the set. So this is what we call what? This is what we call an order pair. This is what we call what? An order pair, because it is ordered such that any value you substitute for x, you have a unique outcome. And you can also represent this in diagram, we have set x, and we also have what? Set y. Please, anytime you are writing this your set, let it be in a capital letter. So we said that if we have the element of x, and we also have the element of what? Y, which is what? Remember, this is your input, and this is what? Your output, which this can also be written as what? F of x. And this input is also called what? The domain. Please don't forget. And this is also called what? The codomain, or we call it what? We call it range. If this map to this, and the elements here, remember the element of x was what? 1, 2, 3, 4. Remember, these are the elements of x we assume. So every time x map 1, we have an image in the y to be what? 5. Every time x map 2, we have an image and the codomain to be what? 8. Every time x map 3, we have a codomain to be what? 11. And every time x map 8, 4, we have a codomain to be what? 14. At this point, we can conclude that this mapping is what? Is a function. That this relation is a what? A function. So now, what is a function? Let's define it generally mathematically. What is a function? We can say that a function is a set of order pairs. A function is a set of order pairs in which no two distinct elements have the same phase entry. A function is a set of order pairs in which no two elements have the same phase entry. What are we saying? We are saying that a function is a sort of rules in which says that every input you put, you have a single output. So if element A has 1, it cannot map to 2 elements in the range. If it does that, it is not a function. Let's use another diagram to explain what I just said. For example, if you have, let's assume we have this set, and we have set y. As this map to this, I have set the element to be A, B, C. And I have here to be 1, 2, 3. Now, if this set map here, and this map here, and this also map here, please look at the board and look at the mapping. A set A is mapping 2 images in the codomain. At this point, this is not a function. According to the definition of what function is, this is not a function. So we said this is not a function. We mark it this way. It is not a function because every element in the domain has a unique element in the codomain. It has a single output. It has a single output. So if it double cross like this, if it maps 2 elements, if it has 2 images in the codomain, it is not a function. So also we can always use graph to illustrate a function. Let's see how we can sketch graph out. If you have a function f of x to be what? 2x plus 1. This is a linear function, right? So every time x takes value from 1, 2, 3, 4, and we have a graph like this, we call this one the y, which is the outcome. We call this one the x. We label it 1, we label it 2, we label it 3, we label it 4. Or we can take even numbers here. Okay, let it be like this. We have here 1, we have here 2, we have here 3, we have here 4. So every time x value is 1, what do we have as the output? Okay, let's assume this was 2x so that we have space to mark the graph very well. Every time there is x value, take the value of 1, we have this place to be 1, 2 of 1 to be 1, 2. If it takes 2, we have 2 of 2 to be 1, 4. If it takes 3, we have 2 of 3 to be what? 6. Next stop there because of space. So every time x is 1, the outcome is always what? 2. So we trace it out and mark here. Every time x is 2, the outcome is always what? 4. We trace it out and mark here. Every time x is 3, we have what? 6. Had it been there is 6, it will be here. And when you draw the line, you see that it is a straight line to this point. Why? Why is it a straight line? Because the function is a linear function. If you were plotting a graph against a quadratic function, you have something like this against a quadratic function, or something like this against a quadratic function. But in this class, we were deliberately discussing what function is. That function is a set of ordered pairs in which no two distinct elements have the same phase entry. So you should be able to always identify a function whenever you see a diagram like this, and you know that every time if any element from say x map 2 images in the codomain, it is not a function. And also know that every function is a relation, but not all relations are functions. For example, this is a function. This is not a function, but it is a relation. So this will end this class in what function is. But in our next class, we'll talk about types of function and types of mapping. So always do well to subscribe on the page and click on your notification button for more videos. Thank you.